This video will provide further information to help understand wind energy projects. First, we'll provide more details on the wind resource so that you can understand what wind speed makes for a good wind resource and what conditions typically create it. Second, we'll provide some data on typical costs for wind projects, and we will explain in what context these costs may vary. Finally, we'll review in further details what makes a project viable, including various streams of revenue, constraints and criteria, as well as strictly financial aspects.
Wind resource. A good wind resource is critical to the success of a commercial wind energy project. The energy available from the wind is not linearly related to the wind speed, but rather increases in proportion to the cube of the wind speed. This means that doubling the wind speed results in 8 times more energy in the wind. The wind developer seeks strong, steady winds with few periods of calm and few storm periods when wind speeds are too high to be used by the turbine. Wind speed typically increases with height above the ground, so when discussing wind speeds, the height of the wind speed measurement must be specified. At minimum, the annual average wind speed for a wind energy project should exceed 4 meters per second, or 14 kilometers per hour, at a height of 10 meters above the ground. Commercial wind farms are usually sited at locations with average wind speeds significantly higher than this. An accurate estimate of the wind speed at a site is very difficult to arrive at without a long-term record of measurements. When measurements are not available, people tend to overestimate the windiness of a site, remembering those dramatic moments when the wind blew with force and forgetting the many hours when the site was calm. Certain topographical features tend to accelerate the wind, and wind turbines are often located along these features. These include the crests of long gradual slopes, but not cliffs, passes between mountains or hills, and valleys that channel winds. In addition, areas that present few obstructions to winds, such as the sea surface adjacent to coastal regions and flat grassy plains, may have a better wind resource. The wind speed often shows a marked diurnal and seasonal variation. Winds tend to be stronger during the day than the night, and stronger during the winter than the summer. Thus, the times of stronger winds tend to coincide with periods of elevated electricity demand, especially in cold climates. The figure on this slide shows the power curve for a hypothetical 1 megawatt turbine. Along the x-axis, values of the instantaneous wind speed in meters per second are indicated. Along the y-axis, the power output of the turbine in kilowatts is shown. At wind speeds below about 4 meters per second, no electricity is generated. The wind speed above which the turbine produces power is known as the cut-in speed. The output of the turbine rises rapidly at wind speeds between 7 meters per second and 15 meters per second, where it reaches a maximum. This wind speed is called the rated wind speed. At wind speeds above 25 meters per second, the wind turbine shuts itself down, and this threshold is the cutout wind speed. Wind energy system costs. Wind turbines that are installed in a wind farm tend to have an installed cost of around $1,500 per kilowatt. In addition to this upfront expenditure, operation and maintenance costs average around 1 cent per kilowatt hour of electricity generated. For comparison, the selling price of electricity from the turbines may be in the 4 to 10 cent per kilowatt hour range. The figure on this slide breaks down the costs of building a wind farm into costs for feasibility study, development, engineering, turbine purchase, and balance of plant. The length of the bar indicates the fraction of the total installed cost of the wind farm that goes into each of these 5 categories. Turbine purchase is by far the largest expense, accounting for about 70% of the installed cost of the wind farm. Balance of plant, which includes electricity transmission lines and substations, is the second most important item, at about 20% of the installed cost. When single turbines are installed outside of a wind farm, or when turbines are installed on an isolated grid, costs tend to be higher. The portions of the total installed cost that are accounted for by the feasibility study, development, and engineering also tend to increase. In addition to the initial costs and the regular operation and maintenance costs, there will be the costs associated with major equipment repair. it can be expected that over the lifetime of the turbine, at least one major component, costing 20 to 25% of the initial costs, will need replacement. Rotor blades and gearboxes are the components most likely to need attention. Wind energy project considerations. A number of factors must be considered when developing a wind energy project. Here we discuss some of the most important. First, as mentioned earlier, a good wind resource is essential to a commercial project. The average cost of generating a unit of electricity falls dramatically with increasing average wind speed. Because the wind resource plays such an important role in the profitability of wind energy, a thorough wind resource assessment is a worthwhile investment for a major wind project. The profitability of a wind project can be significantly improved when the sale of electricity at the market rate is not the only source of revenue. Additional revenue sources may include renewable energy production credits offered by a utility or government, a green power rate premium, or the sale of emissions reductions credits, or ERCs. It is hoped that ERCs, which put a value on the greenhouse gas emissions that will be avoided by the turbine, will in the future become a significant source of income for wind energy projects. A good wind resource and additional sources of revenue do not guarantee successful project development, however. Even the most promising project will face insurmountable hurdles if its planners have not ensured that the site is environmentally acceptable, that the local population supports wind energy, and that an affordable connection can be made to transmission or distribution lines having spare capacity to transport the wind-generated electricity to nearby load centers. Financial parameters also play a major role in the profitability of a wind project. Since wind energy development involves a large initial expenditure that must pay for itself over the life of the project, low discount and interest rates make these projects much more attractive. Procuring financing and convincing investors that the project presents a reasonable risk can represent a significant effort. Currency exchange rates can also impact the profitability of a project. Since most turbines are manufactured in the European Union, and Denmark in particular, developments outside of the EU must pay close attention to the exchange rate between the euro and the local currency. The photo on this page shows one of the 133 turbines installed in eastern Quebec as part of the Le Nordais project, Canada's largest wind park.
Thank you for watching this video. In the next two videos of this series, we will look at some examples of wind projects, and then we will demonstrate the RETScreen wind energy model.